this point, we've actually been making use of this of the train test split to actually split our data for that of the training and also for that of the testing. But there's another way we can actually do this by making use of what's actually called time series split. The way this time series split actually works is this. What it actually does is it splits our data, the data that it currently have. Let's say we have the data, maybe like in our case we have this is actually 15 rows of data here. Let's assume we have 15 rows. It's going to, if we set the number of split to 1, let's say we set the number to 3. Let's assume we have, let's make a smaller example. We have 9 rows of data and we set the number of split to 3. What it means, that 9 is going to divide it by that of 3. Let's actually make use of this of our word part to actually have it. So number of data that we have, let's assume we have total. When I mean number of data, I mean number of rows of data that we have. So it's going to be this of our 9 divided, I will say the number of n is called that of the n what split, and we'll set it to something like 3. So now it's going to be what? It's going to give us 3, right? So these are just supposed to be 3. It's going to give us 3 as the result. What is it going to do? It's going to split our data into 3, and then it's going to start with the first 3. It's going to set this first 3. The first 3 is going to be taken for the training, and it's going to be plus. Like what is actually going to be where it stopped is going to actually go to the next one to actually for the testing purpose. This is what I mean. Let's assume that it's going to start from 0 to 3, right? This is for training, and let's assume this is for testing, right? So 0 to 3 is going to be the first, and then the next thing that is going to do for that of the test, what we are going to have is what? 3 to 6. So it's going to take from the row 0 to 3 for the training. This is actually supposed to be actually 2 actually, but let's actually understand what we're actually doing. So this has, let me go back. This is actually supposed to be let's go back again. This is actually supposed to be our what? Our training, and this is of our what? Our testing. So it's going to go from 0 to what? 2. So it's going to go from our 0 to 2. The reason is basically simple. This total of this is basically 3. So you know that when we do this, what it's going to stop, it's going to at the end, since we have 9 rows, this is actually basically say like 0 to 8, because that's in Python automatically neglects the last since it started from that of the index 0, so the last what it actually said does not actually tend to exist there. So from the look of it, so when since 0 is to 2 is not going to be for the training, for that of the testing is going to start from that of the 3 to what? Instead of it's going to stop in 5, meaning that 3 was used for training and the 3 was used for testing, but it's going to use the future value for training for the testing. So the next thing is going to do is going to start, this is actually for 1, and then the second time is because it's going to run 3 times. The reason why it's going to run 3 times is because we set the number of split to be 3. So the second time it comes on, it's going to start from 0. Now it's going to go to that of 5. So it's going to start from the 0 to that out of index 5. Remember that this is actually for that of the first one. So second time for the training, remember that this is the training size. So it's going to start from that of the 0 to 5. Now what is going to happen is going to start from that of the 6 to what? To our 8. This is actually for testing. You see what is actually happening here. So it's going to, for the next test, it's going to start from that. So it's as if the testing data is the future data of training, and that of the training that we're actually doing is more like the we can say the previous data of the training, and that of the previous data of that of the testing. So when it comes to, because it's going to run 3 times, like I said, it's going to run 3 times. Let me draw this better. It's going to run 3 times. So the next thing is for that of the 3, and then now it's going to go from our 0 to our 8. So for this of the any row exists again, whether if any extra row exists in the future that you can use for the testing. So that's just basically how it works. And the output of this of the time series split is what is going to give you out as an output is going to be that of the indexes that is going to give. And this of the time series split actually belongs to that of the model selection in this of our Sklearn. So with this small ideology that we have here, then we can actually implement on the process. We are going to run it to see what we actually have. So let's actually just close this for now. So this is actually what we're actually able to do in our previous video. For that of regression and for that of the and for classification of that, make use out of the k nearest neighbor. So first of all, we need to from our model selection, we need to actually import our from Sklearn. Like I say, is under that of some model of that of the Sklearn, the sub module which is actually called that of model selection. So we can say from our Sklearn that we have dot what model, that's actual model selection. We want to import what is actually called time, the name alone, time series split. Time series split. So let's actually go back. Let's actually continue. So remember that on the process you can actually train your model with that. So I'm going to make use of that our classification data for this. So let me just get our classification data. And we also have with this of the data frame that we have here, so we don't need to actually start from beginning to write all these guys again. Remember that from what we have here, so we don't need to actually, these actually contain 15 rows for each of the data. So we can actually print our data frame to actually see the result. Then as is running down here, let's actually we need to actually also get for our x and our y, because since we have actually encoded this of the target, because most models don't actually understand string, I can say normal text, so you need to actually convert them to numbers. So with the help of this label encoder, we'll explain what label encoder actually does. We're able to convert it to number, and this of our x was just the input feature that we're going to use to map for the machine learning to find the learn the parameter that actually led to this of the target. So with this, let's actually zoom this, let's widen this. So this is the data that we have and we are going to use for our training. So the target is going to be encoded. This is the value for target, years of experience, the salary, and the age. So since we have actually imported this of our time series split that we have here, so now we are going to can actually create a variable for that. So we can actually call it time series split, any name of your choice, but I'm just going to call it TSS. So I'm going to be time series split, and then you have to set the number of split. That's actually, or default is that of the 5, but let's actually set it to 3. Then we're going to actually see the example. You can set the number of split. You can set it to 3, or you can leave it at default that has been set to 5. But in our case, since we don't have much data, so 3 is actually a good idea. So we can actually see here how it's actually being implemented. So what we can see for our, because this is actually going to return, and this is actually going to run inside the loop. So we can say from our, so like I say for train, because it's going to provide us with the indices that we're basically going to make use of for training. So we can actually just give it train. You can say row, can say training, row, and then it's going to provide us with that of the test underscore row in this of our TSS dot split. Simple as that. So we have this of the TSS dot split, and then remember that we're targeting that of the features, which is the features what are going to set for the model. So the next we want to actually do, because this TSS dot split, remember that TSS name variable I gave for this of the times split. Remember that we said the number of split is going to be 3, like how I explained here. The number of split here, like we say n split, as we set it to be 3 right here. So remember that this is going to provide us with that of the index. So but if you are actually confused, if you actually want to view that, so we can actually say want to actually print our train row. So we can actually create this in a variable. Okay, so we can actually create a test to actually know this is for the training, and then we can actually convert. Let's just copy this. It's almost going to be similar, and the other one was test row. Let's actually change it to test, so we actually know data that we're actually getting. So let's actually run this. As it's running, let's actually look at some of the things that we actually have here. This data that we have here is data we have actually been using. We converted it to that of the data frame, normal pandas data frame that we're actually been doing. So we most machine learning understands numbers. They don't understand text. So we converted it, make use of that label encoder, actually convert it to that of the 0 and 1. And this time series step, like how we actually explained, setting the number of splits is making it. That means this is going to run 3 times. It's going to split your data into 3 times. So it's going to be kind of what is actually splitting that of the features. That's what is actually being splitted, because that's what we said that of the X. So now it's going to provide us with index for our training and for our testing. So it's going to provide us with those of index for training and for the testing. So let's actually expand this so we can actually see what is actually happening here. So this is actually the data which is data frame that we actually have, and then this is for the first training and for the first testing. So we can actually see for the second, and we can actually see for the last. This is actually understandable. Like how I explained, consider the initially is going to split our data into 3. When you split that of the data into 3, where we can see that we have 0 to 5, which is actually a total of 6. I think 15 divided by 3 should be, let's actually do that. That's actually going to be, that's actually 15 divided by 3. That's actually 5. Remember that another thing you can know that some default setting that is on this of the time series split can differ at times. So you can see that for the training, but the one thing you should understand is that the future the value of testing is the future extra value that is going to be set to that of the training. So let's look at this. So for the training, we have this index that we're basically going to use for the training, which is index 0 to that of the index 5, and for the testing is that of index 6 to that of the 8. Then let's look at what happened on the second time that I ran. Remember that the testing was 6 to 8. Now 6 to 8 have actually been added to the training data set, to the training data that we actually that was actually being used earlier. So it's going to be the old one plus that of the testing. So that just basically, if we come here, just like saying old plus that of the testing. This is that of the testing, and this is, when I mean testing, I mean the data set for that of the testing. That just basically is that I can see. So what we can actually see next is going to be this of the entire guide that is here plus this of the 9, 10, 11. So you can see it. This entire guide, just like everything, is going to be incremented plus with the new value that's going to be used for that of the the new value that was actually used for that of the testing. So that just basically how this time split was. So you can actually train when you are training your model initially. So it's going to make use of these indices to actually train the model, and it's going to predict on this. So as you keep on going, the model will keep on try to predict, try to use the data. The training data will keep on increasing. Meanwhile, the testing data actually remains the same. Like you can see, the training data here was 5, now plus 3, and now the plus 3 plus actually plus 3 of the testing data. So you can see the accuracy can keep on increasing or it can keep on reducing, because if it's that some testing might have noise and there's going to be added to that of the training, which can actually introduce a noise. So hope this is, with this example, this actually explaining really better, like everything I was trying to explain earlier. So we have that of the 0 to 5, and for the testing was 6, 7, 8. And now the training now became, before it was 0 to 5, now the 6, 7, 8 that was used for the testing have now been added for that of the training. And for the testing, now the new test is now going to be like the future value of that of the training data. So this is actually the simplest ideology to actually explain it. The future value or the value of testing data is going to be the future value. So there just basically how this things work. So let's actually train our model to actually understand this and actually to make it up. So the first thing we are going to do, since we already know the output that we'll be getting, so we need to actually train our model of which with each of the training data set, and also to test it on each data set. So with the model that will basically be making use of is that of the k nearest neighbor, because k nearest neighbor was the last model we actually used. So I'm going to say our kn going to be k nearest neighbor class 5, because our data, what we're actually targeting is a classification base. If we run this, we're going to get 1010. So it's a classification based type of model. So I initialize our knn here, so which is actually basic. Whether I can actually change this to what model, you can actually change it. So what we can basically do now is actually to, for this of our S train and that of our X test is going to be pointed for our training and for the texting. So we are going to make use of that of the indexing. So we can say our our train, because it's provided with that of the training, and for our S underscore what test. So we can set it to that of the word S. This is actually train row, because the first is going to be for that of the training, and for the other one is going to be for that of the test. Let's actually just copy this. Remember that like we had earlier, is what is actually providing us with that of the let me increase this. So what is actually providing us with is that of the index actually. So can actually it's just more like when we say X index, this is more like saying X index 0, 1, 2, 3, 4, 5. So it's just like saying row 1, row 2, row 3, row 4, row 5. So that's basically what is actually providing us. So we say this is for X test. So this is supposed to be X underscore what test, because the first, which is this S train row, is going to go for the S train, and for the S test is going to go for this second one. This actually makes sense. So we are going to do the same thing for, you can actually continue the same thing for Y, but I would like to actually move it to the second, for the second line. So I think to make sense, this is for the Y train and for our Y test. So this is going to be our Y for the Y train. This is going to be our Y for the Y test. Hope this is now actually how to actually understand what is actually going on here. This is just like saying inside there we are going to have another brace. So it's just inside there as if we are going to have one, two, so let's say 1, initially 2, 3, 4 inside there, because that's actually now this X is pointing directly to our S variable here, which is actually pointing to this all these features there. So it's going to be like a salary feature in the 0, 1, 2, 3. That is for the training and for the testing. I want to see wondering why I put this double quotes here. So that's I think that actually explains it better. So let's actually view one of them, like that of the S test and for that of the Y. So S train and that for that of the Y train. So let's actually print. After we're still going to get the same thing for our S train, like how we actually saw earlier when we ran it down here. We're still going to get exactly the same result. So there's no need of actually running it again. But if we print our, okay, let's actually print it. So let's actually see that. So we have our S, this is going to be our S train. So we're going to have our what? S test. This is going to be gibberish because we didn't actually format it really well. So this is going to be for our Y train and for our Y test. Or we can actually just print each other. So it's still going to be the same thing with this of the row that this particular the test the output are still going to be exactly the same thing. So let's actually wait for it. But as we're waiting for it now, we can actually fit our model to actually learn from this of the S test. Sorry, for this of the Y S train and this of the Y train. So what do I have here? In the 0 not in columns, unexpected key error, no Everything looks okay. Okay. The most problem we have here, where did I get these tests that this variable I'm actually using? What is this? This is supposed to be our test row, not our X test. So this is actually going to fix our problem, because this is actually what we were actually looping through that of the test row and the train row. So let's actually print it out. Then we're going to see some other things. Let's actually run. So even after fixing this, we're still getting this problem. We have the f non key index as its name colons. I don't really know why this error is actually occurring. The reason is still unknown to me as of now. So I can basically use make use of that of the ilog to actually solve this problem. So I can just directly make use of that of the ilog. We can say our x.ilog to actually target that particular index on our x-axis. So I can also do the same thing for our ilog. So we can actually just target that particular. So we know that dealing with that particular x-axis. So I think that from the look of it, you can see none of index 0, 1, 2, 3, 4, 5. The data type is that of int 64 in colon. So I don't really know why this problem is actually doing like this. Let's actually run it like this to see whether if this actually fixes a problem. It doesn't actually work. We'll do the same thing for the y and for that of the y training and for that of the s training. So if everything works out really well, we're going to now fit our model to this of the s train and that of the y train, and then we're going to see each of the everything seems to be working really well. Now I think basically the reason because of we didn't make use of ilog to target that particular you can say that particular rules of our choice. So at the beginning, this is actually the everything look messed up. This is for the training thing. I wonder why we are still getting this data frame actually popping out. Okay, that's actually for the you can see it keep on increasing. Initially it actually go up a little bit. This is actually the main data frame itself, the main data itself. So when we look at this of the training now is 0 to 5, and then the testing now is 6 to 7, like how we actually saw before. Now you can see it was 0 to 8, now 0 to 8 because now the testing has actually been added to it. So when it runs again, it's going to be incremented. So everything looks really good. At the last point, was able to increase to that of the 15. I can say, remember that this actually does it step by step, like takes from 0 to 5, like how we actually saw earlier. So no need for us running all these guys again. We can actually get rid of it, or can just comment it out. So it will mess our script really. So the next we want to actually do, let me get this guy out. So we shorten down of our data the main data frame. So the next we want to actually do, make use of this of our S train, our S test to actually fit our model. So it's basically simple. So we are going to say this is our model. We want to actually fit it to our S train because we know what S train actually is. That's more like the mode of the data and that of the Y train. So if you make use of the S test, if you make use of the S test, your testing data is not going to be more than your training data, which is on a nutshell doesn't even actually make sense. So this, you can see how this works different or like that of the train test place. So for the evaluation, I will make use of this of the accuracy. So I can make use of, I'm going to predict that of the S test, because the S test is actually what we are going to predict. So let me actually just comment this and then push it inside. So it's going to be, I'm going to predict that of the S test because the model have not seen that of the S test, and which was what was reserved for the testing of the model accuracy score, how to actually to know the accuracy, the confusion matrix. So let's actually focus on that of the accuracy. So as the data increases, definitely the model is going to learn more. I think the accuracy is going to increase because data actually increases, and at times at a particular point you can have if you find out that the model accuracy actually reduced, that can be a cause that that can actually allow to that, or the new data that was actually being forwarded has some maybe noises, or maybe we make your model to learn new stuff. So how you can see here, the initially or normally the test data is basically going to be the same size. So you predicted 1 at this particular point when the test data was the training data was only just, I think that should be 5, or that was 5 or 6. So model accuracy was 53.3 percent. And then when the data increased to that of the 5, I think that should be 6 plus 3, that increased to, I think that should be 6, 7, 8, 9, that increased to 9. The model was able to accuracy was still at that of the 3.3, but when the data increased for that of the 9 plus 3, that should be 9, 10, 11, 12, I think that should be 12. And then the model accuracy came up, because now the model actually learn new things. So these are basically you can make use of this of the time series split.